Okay, great. So now we're going to use fmin bound to try to have some fun with our projectile motion problem. So you are going to need several functions. So you're going to need initial coords, initial velocity components, quadratic, and landing distance from your homework stuff. And then I have given you a function called SquaredDistanceDiscrep. And so let's go ahead and open that up and take a look at it. Okay, so function is SquaredDistanceDiscrep with a crazy typo somehow, which we should fix. I don't know if yours is like that or not, but it should be spelled like that. The inputs to this function are theta, the launch angle, the d values, the initial velocity, and a target distance. Okay, and then the output is this variable called SquaredDiff_dist. Okay, so what on earth is that? Let's take a look at what's inside this function. So we call landing distance and give it its inputs, dv0 and the launch angle, and assign the output to xland. Alright, so we're computing xland, and then we compute diff_dist, which is xtarget minus xland, and then we square diff_dist to get the squared diff_dist. Okay, so basically we're taking the difference between xtarget and xland and then squaring it. Okay, so the first thing we should probably do is just call that function and sort of see what that looks like. So scroll down in your notes script here to where it says projectile example, and I've already defined some inputs for us. So xtarget is going to be 0.8, the d values are just going to be 0, 0, 0 to keep things simple, and then v0 will be 3.5. Alright, so let's follow the instructions here. So it says we should call our SquaredDistanceDiscrep function to get the squared difference between xtarget and xland for a range of launch angles. So let's say that theta is equal to 1 in increments of 1 degree up to 90. Alright, and then we can say, let's use SVD for squared distance discrepancy, and call our SquaredDistanceDiscrep function and give it the inputs that it needs. So theta, d, v0, and x target. Alright, we've already defined all those things, so that should be fine. Okay, and then we'll plot theta on the horizontal axis and SDD on the vertical axis. We should probably do another clear CLC close all. And then for good measure, before we call plot, let's open a new figure window. Alright, so let's run this section. Oh dear, I don't have my function files in my folder. That is not good at all, but let me see how quickly I can find them. Actually, I think okay, I found my function, so let's try to run this section again. And there is our plot. And what you'll see is that there are two local minima, right? Around 20 and around 70, and it looks to me like the minimum value is 0, which makes sense because at some point the difference between xtarget and xland will be 0, and the square of that will be 0. Okay? So our job in the next video will be to use fmin bound to find this local minimizer and to find this local minimizer, so we know the shallow and steep launch angles to use to hit a target.